a different convolution, but same convolution done in blocks. Okay, so if you have a sequence X of n, let us assume it's going to be long. Goes on, okay, it's infinity. Now what we do is, this is a big block of signal, okay? We divide this into smaller blocks. And then we can call this as x1 of n, x3 of n, etc. We already know h of n, which is of a finite length. Okay. Let us assume. Okay, this is just an example. So you have h of n already, it's a finite length sequence. And the infinite length sequence, as it is coming at real time, you can divide it into smaller blocks. When 3 samples come, you can find the DFT of this block, DFT of this block, multiply them and get y1 of n. Okay. Same way, x2 of n. The next block comes, the next DFT, next convolution, and so on. This is called as block convolution. Okay. This is the basics about block convolution. So these are some of the convolution facts which we have already seen. So repeatedly I'm telling these words are interchangeable. Okay, convolution generally means linear convolution, and convolution operation is also known as filtering. And DFTs are always associated with convolution in digital signal processing. The product of 2 DFTs is used to find the output of the LTI system. And the fastest method to perform convolution is using FFT algorithm. In real-time applications, when the input signal is of infinite length or very long, then the usual way of performing convolution is not possible. And if if n is too large, if you take a bigger block, then there is a significant delay in the processing that affects, the output comes later, right? So the block size should be small as possible. So the input signal is partitioned into smaller blocks, and hence allows the FFT algorithm to perform convolution in a continuous manner. So as I said, the input signal is divided into fixed blocks before processing. Then convolution over each block with the impulse response is done. Then you get some output blocks, right? First convolution, first block, second convolution, second block. So they can be connected in a convenient way so that you get the correct output. The advantages of block convolution. Samples of the output will be available real time on a block by block basis. Block convolution can be divided into 2 types. One is the overlap add method, and the other one is overlap save method. These are the outcomes are the same, okay? Only the way in which it is done is different. Let's see overlap add method. So let's assume the length of x of n is going to be infinite. Okay? And the length of h of n is finite, and it is m. Okay, so one of the signal is of length of, you imagine there is samples, okay? So it's of infinite length, of course. The other one is of smaller length, that is m. So now x of n is divided into blocks of length L. We are going to divide this into blocks of length L. Okay. So I'm showing only 3 blocks here for convenience. Excuse me. So what have we learned till now? In order to perform convolution, linear convolution using DFT, what should be the criteria is to have both the blocks of length, both the blocks should have a length equal to m plus L minus 1, right? So they are of different lengths. M and L are different. M can be greater than L or L can be greater than M. So since we are going to perform the convolution block by block, we are going to separate the blocks and then make each block equal to a length m plus L minus 1. Okay. So this is m. How do we make the length of the impulse response to m plus L minus 1? You pad zeros. Okay. So this block has zeros. The L minus zeros can add. Now you see the length is m plus L minus 1. And the corresponding DFT is h of k. Okay. Let's take the first block. The first block is of length L. How many zeros will you pad here? M minus 1 zeros. Okay. These are all zeros. The number of zeros will be m minus 1. So simultaneously when we show, we can show it as different blocks. Okay, and this is the corresponding DFT of that block. You already know how to find the DFT of a given sequence. Now the second block. You can see that I have just drawn this below at this point where we broke that block. Okay. So this also has again m minus 1 zeros, and the corresponding DFT, if you compute, it is going to be x2 of k. Same way the third block, x3 of n and x3 of k. Okay. All together, that is x1 of n plus x2 of n plus x3 of n. That is before padding. Before padding the zeros, this will be equal. After padding the zeros, also it will be equal. Why? Because these are only zeros. If you add them, again the same. Okay. So now I got all the blocks. You can multiply x1 of k with h of k, x2 of k with h of k, and then x3 of k with h of k. And then find the corresponding output blocks y1, y2, and y3 by finding the IDFT. Okay, let's assume you have multiplied x1 of k and h of k, then took the IDFT, you will get the first block, output block. You can see the output block's length is m plus L minus 1. Okay. Same way, if you find the second output block, after finding the IDFT, There is a overlapping here. Okay. Why? Because the blocks are already overlapping. The third block, after finding the IDFT, will be this. So all the blocks are of length m plus l minus 1. Now in the overlap add method, you get the output by simply adding all the blocks. Okay. That means you are adding the overlapping points. How many zeros you added, that much overlap will be there. Okay, that must be added. Suppose you added 2 zeros here, 4 zeros are added here, then the number of overlap will be 4 points. You have to add them. Okay, here also, you have to add these points and get the final sequence Y3FN. So you can see here, by the time the second block output is ready, you have the output up to this point. When the third block comes, you have the output. So the output is also generated simultaneously as and when the input arrives. This is a theory about overlap add method. So this last line is the final block of the output, combined block. Let's do one problem. Perform block convolution using overlap add method over the two sequences. H of n is equal to 2, and x of n is equal to, we are given a 6 sample signal. So normally, if you are not asked to perform block convolution, how will you do this? You have 6 samples here, 2 samples here. So 6 plus 2 minus 1, 7. Minimum 1 0 you have to pad on the x of n, and how many here? 5. Okay, and then you can use FFT, compute x of k, h of k, multiply them, and then find the IDFT. So you can make it 7, or you can add one more 0 and make it 8. Okay. Now for O, you are supposed to do using overlap add method. Divide it into blocks of 3. It's your choice unless it's given. So here in this example, I am going to use block size of 2. So I will define x1 of n as 1 1, x2 of n as 2 2, and x3 of n as 1 1. In the exam, what you can do is you can see the sequence and explore its symmetry. Okay, if there is some similar pattern existing, then you can divide the block in that way, because you can reduce your computations. For example, if I take x1 of n as this, x3 of n and x1 of n are same. So when I compute x1 of k, my x3 of k also will be available. Okay, so like that you can choose intelligently. So the length of h of n is 2. I'm going to take 3 blocks. So length of each block is going to be 2. So to perform block convolution, each block must be made to a size equal to 2 plus 2, 4 minus 1 is equal to 3. 3 is a little difficult, right? So we can make it 4. So length of each output block will be 3. Since computing a 3-point DFT, you already know is complex, we can make the length as 4 by padding 1 single 0. Okay, so let's make it equal m plus L minus 1. We are adding one extra 0. So you can see I have added 2 zeros here for each block. Now my job is to find h of k, x1 of k, x2 of k, x3 of k. Okay. And then multiply them. Multiply h of k with this, h of k with x2, h of, and then find the IDFT. Okay, so let's find out h of k. There will be 4 samples in h of k. You have this, remember the W matrix. Since it's 4 point, you can use the W matrix, 4-point W matrix. See, the values are 4, 2 minus J2, 0, and 2 plus J2. Symmetry has to be verified. Otherwise, your computation might go wrong. Now, what is the next step? See, all of you do these problems at home or hostel, wherever you are. Now, the next one, x1 of k. You can see the values are 2, 1 minus j, 0, and 1 plus j. Okay. Now, you need to multiply these two. 4 into 2, 8. 2 minus j, 2 into 1 minus j, 0 into 0, 1 plus. Sample by sample multiplication. So the values are 8 minus j, 0, and j4. Now you can find y1 of n by taking the IDFT. So here we have 1 by 4. And this is the W conjugate matrix. The values are 2, 4, 2, 0. That extra 0 we added is appearing here, 0 itself. Check that. So this is the same as y3 of n, right? Now we can do for x2, the same thing, x2 of n. So you find x2 of k. It is 4, 2 minus j2, 0, and 2 plus j2. And then you can find out the product. Find the inverse, you get 4, 8, 4, 0. This is y2 of n. So now we have y1 of n, y2 of n, and y3 of n. Okay. Y3 of n is the same as y1 of n. Now how do we overlap this? We padded 2 zeros, okay? We padded 2 zeros in the beginning. So the overlap will be 2 points, 2 samples. You can see this is the first block, second block, third block. You can add them together. So this is the final output of block convolution. And if another block comes, we will have different values starting from here. Up to this point, it will be correct. Okay. will be the output YFN. It's clear, Anu? Should I go still slower? I think I'm going very slow. Okay. Okay, നമുക്ക് അടുത്തത് നോക്കാം. So in your exam, if you are asked to find the block convolution using any method, most probably you will have a choice to choose your block size. Okay. The next one is overlap save method. Here the only different thing is, how do we make this the same? You have the same impulse response HFN is of a block size M, and then you divide the thing into L minus L sized blocks. The difference lies in the padding of zeros. Okay. We need to make the length equal to M plus L minus 1. Instead of padding zeros, okay, we will take values from the previous block. Some portion of the previous block will be taken to make it of length M plus L minus 1. Okay. So the same way X of N is divided into blocks of length L. And you're supposed to make sure it is greater than M, but for classwork, small problems, you can choose your own. You can take it to be equal also. To perform linear convolution between two blocks, so you are going to ensure that is M plus L minus 1. For HFN, there is no previous block or next block, so you cannot take from the previous block or next block, so only zeros are padded. In the case of X of N, M minus 1 values are taken from the previous block. They are not zeros. We are not padding zeros in overlap save method. So pictorially, you see that the impulse response, you have H of K. The first block. The first block doesn't have any previous block. So we will be padding zeros for that. Okay, M minus 1 zeros. The second block to the corresponding X1 of K DFT. Okay, the second block takes value from the previous block. That is, if this is 2, this will be 1, 1, 2, 2, like that. Previous block values. And the corresponding DFT is, okay. The third block again M minus 1, previous values from here, this end, 2, 3, 4, like that. Now again, the procedure is the same. You multiply H of K and X of 1 of K, H of K, X2 of K, H of K into X3 of K, and then find the IDFT. So you get 3 blocks of output. Now, can we combine it in the same way as we did in the earlier case? No, because there we padded zeros. So we are adding. Here, we are not padding zeros, but we are padding some values from the previous block. So We cannot add them like that. Okay. So let's find the first block. Y1 of n. So what we are going to do for this method is we discard these points which were padded from the previous block. Okay. So here also you are going to discard these points. You're not going to use these points because they are repeating. The same block will be available here two times. Okay. Here also 2 times. So you discard this one. Discard these blocks and then combine them. After discarding, you can simply add them. This is overlap, same method. This is slightly different from the previous method. Whenever we are doing overlap, same method, if you are asked to do, you have to be a little bit careful. Okay. Let's do an example for this also. So here, similar problem. There looks a pattern. 1 and 2, 1 and 2, 1 and 2, like that. So you will feel that you are going to divide this into blocks like this, right? So since we are padding from the previous block, there will be an extra block appearing. Okay. Can you see that? So this block could be like this first block. Just for example, I'm saying, okay. The second block would be like this. Can you see one more block coming? It's a 2 here. Then the rest you can have zeros. So even though you divide it into 3 blocks, you will have 4 blocks. Okay. That is it. You will have to be very careful while doing putting the blocks here. There will be always an extra block coming because the next block takes previous values. See, after this it is 0, 0, 0, right? There is still one more block coming into picture. I hope it is clear. Looks like number of blocks is 3. Though we divide it into 3 blocks, an additional block will appear because the next block will be having the values from the previous block. So you can have an imaginary extension to the sequence with zeros. Okay. Therefore, number of blocks will be 4. Is that clear? The length of each block is going to be 3. So how many zeros we need to pad? 3 plus 2 minus 1 is equal to, the length should be 4. So for all of these, you will pad 1 0. With these blocks, you will pad 1 0. And for this, you will pad 2 zeros. Okay. Sorry, not zeros, right? You're not going to pad zeros. You're going to pad the previous value. The first block you will pad zeros. Okay. The first block will be 0022. Okay. That's a mistake there. Typo is there. This is not 220. It should be 0022. I'll correct this before sharing. So here you can see there is 10. This number is carried over here. Same way this one is carried over here. This is carried over here. And procedure is the same. Multiply all the VFTs and then find the IDFT. So you get 4 plots. So here also there is a mistake. So it has to be 0022. So mistake. I'm really sorry. Okay, that was not a mistake. നമ്മളിവിടെ ബിഗിനിങ്ങില് can see the zeros are padded at the end only. Okay, I confused it. Sorry. നിങ്ങൾക്കും ഇങ്ങനെ such confusions may come. So 2 zeros are padded at the end only. The values are only, the values are correct here. Okay. They are 4, 2 minus j2, 0, 2 plus j2. Sorry. So then you get x1. So you got y1, 4, 2, 6, 4, 6. Okay. Same way you find out y2, y3, y4. Now you can overlap them and process. The red ones are the ones that has to be discarded. Okay. There was only one overlap. So you can put them. Overlap should be only one sample. നമ്മൾ ഒരു വാല്യൂ ആണ് പ്രീവിയസ് ബ്ലോക്കിൽ നിന്ന് എടുത്തിരിക്കുന്നത്. Now you will discard these values. And then collect all the rest of the values. So that is about block convolution. ഇനി നമ്മൾ ചെയ്യാൻ പോകുന്നത് A batch, I have done some problems in the class for FFT and all. So only B batch need to fail. We take the attendance for A batch. Batch can be around. Batch can stay. Okay. Batch. Ardra
Present, miss.
R. Omal.
Present, ma'am.
Those who give the attendance, you can go if you want, okay?
Present, ma'am.
Abdullah,
Present, ma'am.
and Abhijit.
Present, miss.
നിങ്ങളുടെ മൈക്ക് മ്യൂട്ട് ചെയ്ത് വെച്ചിട്ട് നിങ്ങൾ സംസാരിച്ചാൽ എനിക്ക് കേൾക്കും. കേൾക്കുന്നുണ്ടോ ഞാൻ വിളിക്കുന്നത്? Abhinav Krishna absent. Abhinav Krishna VV.
Present, ma'am.
Okay. Abhiram.
Present, ma'am.
Abhishek PS.
Present, miss.
Adityan.
Present, miss.
Adnan. Adrija.
Present, miss.
Adul.
Present, miss.
Ahanya.
Present, miss.
Ahanya ഉണ്ടോ?
Present, miss.
Ajay.
Present, miss.
Alvin.
Present, miss.
Amrita. Amrita absent ആണോ? Anantagopal.
Present, ma'am.
Anandan.
Present, ma'am.
Anandu.
Present, miss.
Anup.
Present, miss.
Anugrah.
Present, miss.
Aarti.
Present, miss.
Ardra.
Present, miss.
Arjun.
Present.
Ashmi.
Present, ma'am.
Azrun.
Present, miss.
Bhagat S.
Present, miss.
Bhagat TP.
Present, miss.
Chaitanya.
Present, miss.
Dania. Dania absent. Dheeraj.
Present, ma'am.
Devadatt. Devanarayanan.
Present, miss.
Devanga.
Present, miss.
Don Joseph.
Present, miss.
Rishika.
Present, miss.
Elnio.
Present, ma'am.
Fahad. Absent. Govardhan.
Present, miss.
Gautam.
Present, ma'am.
Gopika.
Present, miss.
Gauri.
Present, miss.
Adi. Hamdan,
Present, ma'am.
Aneen, absent. Ritik, Nikesh,
Present, miss.
Isan, absent. Ivana,
Present, ma'am.
Jacob,
Present, ma'am.
JC,
Present, ma'am.
Abel, absent. Riteya, absent. Jyoti, absent. Sri Lakshmi,
Present, miss.
Pranav,
Present, miss.
Varun,
Present, miss.
ഓക്കെ എല്ലാവർക്കും പറയാനുള്ളത് for the series test you have to prepare well, okay, from DTFT to DSP process complete ആയിട്ട് prepare ചെയ്യണം. You need to prove some of the properties of DTFT and DFT. എല്ലാം 4.DFT ചെയ്യാൻ പറ്റണം, FFT ചെയ്യാൻ പറ്റണം. ഓക്കെ, നിങ്ങളൊക്കെ പോകാം, A ബാച്ചുകാർക്ക് പോകാം. B ബാച്ച് alone can stay because ഒരു പ്രോബ്ലം പോലും ഹാൻഡിൽ ചെയ്തിട്ടില്ല. Or anybody else who wants to listen also can be there. Absentees അങ്ങനെയുള്ളവർ.
മാം
Yes.
ഫഹദ് പ്രസന്റ് ആണ്.
എന്താ ഫഹദ്, ഞാൻ വിളിക്കുമ്പോ ഉണ്ടായിരുന്നില്ലല്ലോ ഇവിടെ.
മാം അത് അപ്പൊ കിട്ടിയില്ല, ഓണാക്കാൻ പറ്റിയില്ല. പിന്നെ എ കഴിഞ്ഞിട്ട് പറയാൻ വിചാരിച്ചു.
Okay.
മിസ് ദേവദത്തും പ്രസന്റ് ആണ്.
Okay, let's go for the B batch students. നമുക്ക് ഒരു FFT പ്രോബ്ലം ചെയ്യാം ഇപ്പോ. Okay. എല്ലാവരും അവരവരുടെ നോട്ട്ബുക്കിൽ ചെയ്യണം. Because you are only going to tell me the values. I trust at least one person will do. Okay. Okay. I think you can see the PPT, right? So the problem നമ്മൾ ചെയ്യാൻ പോവുകയാണ്. Compute the 8.8t. Think decimation in time and FFT algorithm. So copy down the question. നമുക്ക് ടൈം കിട്ടുന്നോ ഇല്ലയോ എന്നൊന്നും നമുക്ക് അറിയില്ല. Okay, we don't know about the climatic conditions. We don't know what's going to happen. If at all we get a class, we will do some problems in the class. Okay. ഇത് നിങ്ങളുടെ റെസ്പോൺസിബിലിറ്റി ആണ് ഇത് ഓരോന്നും ചെയ്ത് പഠിക്കാന്നുള്ളത്. Okay, have you copied the question? Because ഇത് ഒരു പ്രാവശ്യം അറ്റ്ലീസ്റ്റ് മാനുവലായിട്ട് അവരവർ ചെയ്തില്ലെങ്കിൽ it will be very difficult for you to understand. Okay. So first ഈ സ്കീം എങ്ങനെയാണ് ലെജിബിൾ ആയിട്ട് വരയ്ക്കുന്നതെന്ന് ഞാൻ പഠിപ്പിച്ചു തരാം. So how do we legibly draw this figure? To compute a 8-point DFT, I kept my pen somewhere, just give me a moment. Okay. Now, how do we do this scheme in a very legible way? Like 8 parallel lines varaikkum, okay? 1, 2, എല്ലാവരും എൻ്റെ കൂടെ ചേർന്ന് ചെയ്യൂ, okay? Whoever wants to seriously learn this. 3, 4, 7, 8. You can do it stage by stage also, or completely full ആയിട്ട് ചെയ്യാം. Now you can put here x of 0, x of 4, x of 2, x of 6, same way x1, x5, x3, x7. We saw yesterday the inputs are arranged in the bit reversed form. You see, this is 0. This is the first sample, second sample. This is the 4th, 5th, 6th, and the 7th. So what will come here? Here you get half. 4th sample is 0. Second sample is half. 6th sample is 0. First one is half. 5th is 0. Third is half. ചെയ്തോ എല്ലാരും? Have you drawn? Now the first നമുക്ക് എല്ലാം ഒരേ ലൈനിൽ വരണമെങ്കിൽ you will have to put the nodes here in straight lines. Otherwise, each node will be lying somewhere and it will look ugly finally. And then this is addition, okay? This is subtraction. And there was a W8 of 0 here. Multiplier. Here also, one addition, one subtraction. Every butterfly has one addition. The upper one is addition, lower one is subtraction. Before subtracting, we multiply with the W8 and then subtract. Okay, what are the values that you will get at this point? Addition. Half plus 0 is half. Okay. Half minus half is, half minus 0 is again half. Can you fill the rest of the points? ഇത് മനസ്സിലായോ? Top is addition and bottom is subtraction. Okay. So same thing you can do here. Half plus 0, half. Half minus 0 is half. Half plus 0 is half. Why there is only addition and subtraction? Because W8 of 0 is 1. W8 of 0, the value 1 ആണ്. So if you see, all the values are half. Clear alle? Now we can do the second stage. Second level. Second level, you again give a lot of space in between, because you're going to write over this. First, നമ്മൾ രണ്ടായിട്ട് combine ചെയ്തു. ഇനി 4 ആയിട്ട് combine ചെയ്യും. Okay. A straight line. So, ഇതിന്റെ മേലെ ഇരിക്കുന്നത് first 4, bottom ഇരിക്കുന്നത് second 4. Now you have overlapping butterflies. Okay. You're going to upper 2 and lower 2 in the upper half. Okay. So you're going to combine these, add these two, subtract these two, subtract these two. Subtraction has to be indicated with the minus sign. Before doing that, we need to multiply with 0 and W8 of 2. W8 of 2 minus J. Okay, so minus J. So multiply J. Yes. Can you find out what are these values? ആരെങ്കിലും പറയാമോ ഇവിടെ എന്താ വരുന്ന? Chat box ൽ അടിക്കാം. What will be the value at that point where there is a question mark? 1, yes. So this is going to be 1. Half. ഇവിടെ നിന്ന് വരുന്ന ഈ പോയിന്റിൽ നിന്ന് വരുന്നത് ഹാഫ് ആണ്. ഈ പോയിന്റിൽ നിന്ന് വരുന്നതും ഹാഫ് ആണ്. So half and half you are adding here. Now half minus half. അല്ലേ ഇവിടെ? It will be 0 here. Okay, now tell me the second value. Tell me the second value. Half minus J by 2. Yes, exactly. So ഇവിടെ നമുക്ക് വരുന്നത്, from this line you can see the previous value is half. And here it is half into minus J. So half minus J by 2. Okay, and what about this point? Anybody? Half plus J by 2, yes. ചെയ്താണ് പറയുന്നു ഞാൻ വിശ്വസിക്കുന്നു. Half plus J by 2. Same way you can do for the lower side also. this and this goes to plus, and this goes to plus. Idum minus, idum minus. So what are the values you will get here? Lower half le endokya varum? Similar ആയിട്ട് തന്നെ വരും. Upper half പോലെ തന്നെ അല്ലേ? It's like a replica. So if you are very good in maths, you will know that this is also going to be half minus j by 2, 0, half plus j by 2. So now the next stage, കുറച്ചുകൂടി space വേണം because you are going to have w factors there. Straight. Here also you can draw the nodes first because they will look legible. Then you can now combine the upper half and the lower half like this. You have to do it neatly, okay? എനിക്ക് ഇവിടെ control ഇല്ലാത്രയും. The lower one is subtraction. So there should be a -1 sign everywhere. -1. So before that, നമ്മൾ എന്താ ചെയ്യേണ്ട ഇവിടെ? You need to multiply with the w's. 8 of 0, that is 1. W 8 of 2 ഇവിടെ വരും minus j. Then here, one by root 2 into 1 minus j. One by root 2 into 1 minus j. Here, minus 1 by root 2 into 1 plus j. ഞാൻ ഇവിടുത്തെ multiply. So how do you get this value? You add 1 and 1, you get 2 here. അടുത്തത്, you should use your calculator, okay? Should use your calculator. You have to multiply. You can put it in complex mode and then multiply this complex number with this complex number. രണ്ടും കൂടെ multiply ചെയ്തിട്ട് വേണം. You have to add it with this number. Clear? Can you do it? And your number which you are multiplying should be a clear number of the form a plus jb. University exam ayalum, class internals ayalum, the number has to be like this. It should not be like this, 1 by 2 minus j by 2, okay, plus half minus j by 2 into 1 minus j into 1 by root 2. ഇങ്ങനെ എഴുതി നിർത്താൻ പാടില്ല, okay? This number has to be properly computed and it has to be brought into a pure a plus jb form. So you need your calculator and you will do it using the calculator. Is that clear? Numbers ingane hang cheyan paadilla. You might be lazy, you might be you might not have the calculator. That's not the right way to do. Okay, so I'll go to the next slide. You can see the values which we have done there. നമ്മൾ അവിടെ handle ചെയ്തത് just here. These are the final values. The numbers, ഇപ്പൊ ഞാൻ എഴുതിയിരിക്കുന്നത് കണ്ടോ ഇവിടെ ഈ ഫോമിൽ വേണം അത് കൊണ്ടുവരാൻ. ഓക്കെ, ഇങ്ങനെ ക്ലിയർ നമ്പേഴ്സ് ആയിട്ട് ഇരിക്കണം ഫൈനലി. And the scheme, you have to learn the scheme, how to draw the scheme, the basic scheme with all the W's properly. Monday or Tuesday, when is your class? Monday afternoon alle. So Monday if you get time. Monday afternoon ആണോ അല്ലല്ലോ, Tuesday morning ആ? ആരും ഇല്ലേ ഇവിടെ ക്ലാസ്സിൽ? ടൈം ടേബിൾ നോക്കി, ടൈം ടേബിൾ ഓർമ്മയുണ്ടോ?
Tuesday morning.
ഓക്കെ, സോ ട്യൂസ്ഡേ മോർണിംഗ് നമുക്ക് കിട്ടുവാണെങ്കിൽ നമുക്കൊരു പ്രോബ്ലം, ഞാൻ ഐ വിൽ ഗിവ് യു എ സ്മോൾ ടെസ്റ്റ്, യു ക്യാൻ ഡു ഇറ്റ് ഇൻ ദ ക്ലാസ്. ഓക്കെ, 2-3 ക്വസ്റ്റ്യൻസ് ഐ വിൽ ഗിവ്. എല്ലാ പോർഷൻസും പഠിച്ചിട്ട് വരണം. ഇസ് ദാറ്റ് ക്ലിയർ? അപ്പൊ ഇത് ഇങ്ങനെയാണ് ഈ പ്രോബ്ലം. യു ക്യാൻ കംപ്ലീറ്റ് ഇറ്റ്. ഓക്കെ, ഐ ടോൾഡ് യു ദ പ്രൊസീജിയർ. ഇതെല്ലാം ശ്രദ്ധിക്കണം. ഓക്കെ, ഇവിടെ ഇതൊരു DC വാല്യൂ ആയിട്ട് വരുന്നത്, ഇതൊരു കോംപ്ലക്സ് കോൺജുഗേറ്റ് ആയിട്ട് കാണുന്നത്. സോ ഇഫ് യു ആർ വെരി ഗുഡ് ഇൻ യുവർ computations, you have proper focus, you need to compute only 1/2 of this up to this point. ബാക്കി എല്ലാം നമ്മൾ ഓട്ടോമാറ്റിക് ആയിട്ട് കോൺജുഗേറ്റ് ആയിട്ട് എഴുതി പോകാം. The same way, so ഈ പ്രോബ്ലം നോക്കിയാൽ ഇതിൽ 6 സാമ്പിൾസേ ഉള്ളൂ. കമ്പ്യൂട്ട് ദ DFT of x of n using DITFFT algorithm. 6 സാമ്പിൾസ് ഉണ്ടെങ്കിൽ നമ്മൾ എന്ത് ചെയ്യും? 8 ആക്കണം, സീറോസ് എക്സ്ട്രാ ആഡ് ചെയ്യും. പിന്നെ സെയിം തിങ് യു ഹാവ് ടു റിപ്പീറ്റ്. ഓക്കെ, ഇൻ ദ കേസ് ഓഫ് ഡെസിമേഷൻ ഇൻ ഫ്രീക്വൻസി അൽഗോരിതം നമ്മൾ എന്ത് ചെയ്യും? We will put the sequence in order. Okay, put the sequence in order. Okay, this is the scheme for decimation in frequency. Okay, you have this in order. Okay, the input is in order, and then you add and subtract in the beginning itself, then multiply the W factors. Same, similar ആയിട്ട് തന്നെയാണ്, addition, subtraction, upper half. And then if you see here on the right side, these values are in the bit reversed form. ഇതാണ് ശ്രദ്ധിക്കേണ്ടത്. ഡെസിമേഷൻ ഇൻ ഫ്രീക്വൻസിയിൽ 0426 ഉണ്ടാവും. ദാറ്റ് ഇസ് ബിറ്റ് റിവേഴ്സ്ഡ് ഫോം ഇൻ ദ ഔട്ട്പുട്ട്. then the case of ഒന്നുകൂടെ പറയാം. മൈക്ക് മ്യൂട്ട് ചെയ്യൂ. ഓക്കെ, can you see the problem for the inverse discrete Fourier transform? Suppose you are given only 5 points. Let us assume 1, 2, 3, 4, 5. ഈ പോയിന്റ്സ് തന്നിട്ടില്ല. You are given only this much. Compute the IDFT എന്ന് ചോദിച്ചാൽ എന്ത് ചെയ്യും? Can someone answer? Type in the chat box. Or unmute the mic and tell. Do you know it or you don't know it? അതെങ്കിലും apply answer ചെയ്യൂ. Do you know it? Yes അല്ലെങ്കിൽ no പറയൂ. Can you hear me? കേൾക്കുന്നില്ലേ? എല്ലാവർക്കും ആബ്സെന്റ് ഇട്ടിട്ട് പോട്ടെ. At least tell me whether you can hear me, okay? കേൾക്കുന്നുണ്ട്. So in such cases, if you are given, or the problem will be like this: compute the IDFT of x of k if the first 5 points are given എന്ന് പറയും. Okay, if this word comes first 5, first 6, ഏതൊക്കെ പറഞ്ഞാൽ it means the rest of the 3 points, 5 points കൊടുത്തിട്ടുണ്ടെങ്കിൽ the rest will be 3 points. 6 കൊടുത്തിട്ടുണ്ടെങ്കിൽ 2, 7 കൊടുത്തിട്ടുണ്ടെങ്കിൽ 1. Points need to be found out. Okay, so you will frame the question by adding the conjugate points. So the previous 0 ക്ക് മുന്നേ ഉള്ളത് 1 minus j 0.414 ആണ്. ഇതിന്റെ കോൺജുഗേറ്റ് എഴുതും. Then next is 0. Then next അതിന്റെ കോൺജുഗേറ്റ് എഴുതി you will make all the 8 points. After making the 8 points, you take the conjugate of all the points once again. After that, you choose the scheme, either decimation in time or decimation in frequency. Decimation in time ആണെങ്കിൽ ശ്രദ്ധിക്കേണ്ടത് ഇതിന്റെ ഈവൻ പാർട്സ് you have to number them. Okay, 0, 1, 2, 3, etc. And then അതിന്റെ 0, 6, 2, 4 അങ്ങനെ അതിനെ sort out ചെയ്ത് neat ആയിട്ട് then only you need to find the IDFT. Okay, ഇത്രയാണ് എനിക്ക് പറയാനുണ്ടായിരുന്നു. With this, we'll stop. If you have anything, any questions regarding your internals or anything, attendance to കഴിഞ്ഞതിന് ശേഷം you can ask me, okay? Just attendance. Joel John,
Present, miss.
John Zubin, absent. Julia,
Present, ma'am.
Ananya,
Present, ma'am.
Present, ma'am.
Karina,
Present, ma'am.
Kasinath,
Present, ma'am.
Kiran,
Present, miss.
Nasif,
Present, miss.
Madonna, absent. Manas, Misab, absent. Amin,
Miss Madonna present.
yeah, attendance പറയാത്തവർ later ആയിട്ട് ലാസ്റ്റിൽ നോക്കാം, okay? Amin,
ma'am.
Mohammed Amin absent. ആസാൻ ഉണ്ടോ? റനീം,
Present, ma'am.
ഷസാദ്, തബ്ഷീർ അലി, റൈഹാൻ,
It's present, ma'am. Shehzad present.
തബ്ഷീർ അലിയാണ് ഞാനിപ്പോ വിളിച്ചത്. മുഹമ്മദ് റൈഹാൻ, മുഹമ്മദ് ഷാൻ,
Present, ma'am.
നവനീത്,
Present, ma'am.
നസ്ലുൽ,
Present, ma'am.
നവീൻ, നീരജ്,
Present, ma'am.
നിരഞ്ജൻ,
Present, ma'am.
നിവേദ്, ആബ്സെന്റ്. നോയൽ,
Present, ma'am.
പാർത്ഥിപൻ സി കെ, പ്രണവ് ഒ വി, പ്രണവ് പി,
Present, miss. Present.
പ്രിൻസ്,
Present, ma'am.
പുണ്യ,
Present, ma'am.
രാഹുൽ, ഋഷഭ്,
Present, ma'am.
സഞ്ജന,
Present, ma'am.
സഞ്ജയ് കൃഷ്ണ, സൗരഭ്, absent. സവാദ്,
Present, ma'am.
ഷോമിയ,
Present, ma'am.
സിബിൻ രാജ്, സിദ്ധാർത്ഥ്,
Present, ma'am.
സൗരവ്,
Present, miss.
ശ്രീദേവിക,
Present, ma'am.
ശ്രുതി,
Present, ma'am.
തമന്ന, തസ്ബീഹ,
Present, miss.
തസ്ബീഹ. I'm not able to see your തസ്ബീഹ.
Present, miss.
എവിടെയാ?
മിസ് ഞാൻ എൻ്റെ മെയിൽ വെച്ച് കയറാൻ പറ്റുന്നില്ല, അപ്പോൾ വേറെ ഫ്രണ്ടിന്റെ മെയിൽ വെച്ചാ കയറിയത്.
ഏത് ഫ്രണ്ടാ? ഇവിടെ ഒന്നും
ഷാദിന്റെ
കാണുന്നില്ലല്ലോ.
ഷാദിന്റെ മെയിൽ
ഷാദിന്റെയോ?
വെച്ചിട്ട്. ആ.
അപ്പൊ എവിടെ നിന്നാണ് ക്ലാസ് അറ്റൻഡ് ചെയ്യുന്നത്? അപ്പൊ
ഞാന് വീട്ടില്.
വീട്ടിലാണോ? ഷാദിൻ എന്റെ നെയ്ബർ ആണോ?
ഇല്ല.
പിന്നെ
അത് ഇതില് ലോഗിനായി മെയില് അവന്റെ. അങ്ങനെ കയറിയത്. എന്റേത് പാസ്വേഡ് അടിച്ച് കയറാൻ പറ്റുന്നില്ല.
ഒരേ സമയം രണ്ടുപേര് വേറെ വേറെ സ്ഥലത്തിൽ നിന്ന് ഒരേ ഇതിൽ കയറാൻ പറ്റുമോ?
പറ്റും.
വൈഷ്ണവ്.
Present, miss.
വന്ദന.
Present, miss.
വിനയ.
Present, miss.
വിസ്മയ.
Present, miss.
വൃന്ദ.
Present, miss.
അക്ഷയ്. അബ്ദുൽ.
Present, ma'am.
അസ്ലാം. ഷാദിൻ.
Present.
സായൻ. ഉദയൻ. ശ്രീലക്ഷ്മി.
Present, miss.
സായന്ത്യം.
Present, miss.
Miss Shehzad present.
Sir.
ഓരോരുത്തരായിട്ട് പറയൂ.
Rayhan present. Miss Hadi present.
Madonna present.
Come on.
Ma'am, Rahul is also present.
Okay. റഹാൻ. ഞാൻ മാർക്കട്ടെ ആദ്യം.
Yes, miss.
അടുത്ത ആള്.
Miss Shehzad.
ഒരാൾ പറയൂ.
Miss Hadi.
ആദിയോ? ആദി എപ്പോ ജോയിൻ ചെയ്തു? ആദി
Miss ഞാൻ കോളുണ്ടായിരുന്നു. ഞാൻ ഇടക്ക് ഒരു നടുവിലായപ്പോ കുറച്ച് പോയിണ്ടായിരുന്നു. പക്ഷെ ഞാൻ കോളുണ്ടായിരുന്നു.
No, that is. I didn't see you at all from the beginning.
ഉള്ള വിഷയം ഉണ്ടായിരുന്നു.
എവിടെയാണ് നമ്പർ? എന്താണ് ഹാദിയുടെ?
44. Miss 43. 43.
ഏതാ 43? എന്താ പറയുന്നു?
Miss 43 ECA.
എയിലുള്ള കഴിഞ്ഞ എത്ര? ഞാനിപ്പോ ബിന്റെ അറ്റൻഡൻസ് എടുക്കുന്നു. മൈ ഗോഡ്.
മിസ് അതിന്റെ ഇടക്ക് കുറച്ച് പോയിണ്ടായിരുന്നു. അപ്പൊ പിന്നെ അത് വന്നപ്പോ ഇതിലേക്ക് വന്നത്.
വെയിറ്റ് ചെയ്യൂ. ഓക്കെ, ഐ ആം ഹാവിംഗ് ദ ബി ബാച്ച് അറ്റൻഡൻസ് ഇൻ മൈ ഹാൻഡ്.
Okay.
Miss Shehzad present.
മഡോണ.
Yes, ma'am.
മിഷാബ് ഉണ്ടോ?
Present, ma'am. Mic on ആക്കാൻ പറ്റുന്നില്ല.
അതിലൊക്കെ ചുമ്മാ പറയൂ മുഹമ്മദ്.
അല്ലല്ല കാര്യത്തിൽ
See, that's okay. എനിക്ക് ഇതിലൊന്നും ഒന്നും കിട്ടൂല. ഓക്കെ. അമീൻ ആബ്സെന്റ്. അസാൻ ആബ്സെന്റ്. ഷഹസാദ്
present, ma'am. Miss
Okay.
present.
അടുത്തത് തബ്ഷീർ അലി ആബ്സെന്റ്. മഡോണ ഞാൻ മാർക്ക് ചെയ്തു. മഡോണ can leave. Whoever has marked their attendance can leave. Okay.